you are given the slope and one of the points on the line that's not the y-intercept, you can still use that slope-intercept form, y equals mx plus b. So we're going to use it two different ways. We're going to write the equation in the end in slope-intercept form, but we're also going to use slope-intercept form to help us find the y-intercept. So we're going to use it to help us get that y-intercept. So what should we be solving for in it if we're looking for the y-intercept? What piece of that equation, y equals mx plus b, would we be solving for if we're looking for the y-intercept? B. We would have to find b for it. So what we're going to do is we're going to identify, with the information that we've been given, we're going to identify the parts that we can substitute in and then solve that equation for b. So write the equation of the line whose slope is -4 and the ordered pair -1, 3 is a point on it. How would we know if that was the y-intercept? -1, 3. Is that the y-intercept? You should be able to look at a point and identify whether it's a y-intercept or not. How would we know if it's the y-intercept? X has to be 0. Well, x is not 0 in that one, so we can say, you know what? There's no way that that is the y-intercept, so we're going to have to find it. So in this one, we're going to identify so we're going to use this ordered pair, and the fact that that is our m, we're going to use that information to help us find the b. That's what we're going to be looking for. We're going to be looking for that b. So what is our y value we're going to substitute in? 3 is our y value. What's going in for m? -4. What will we put in for x? -1. And b is what we're solving for. That's the question mark. We're looking for b. So we're going to put 3 in for y, -4 in for m, -1 in for x, and leave it plus b because that's the one we're solving for. So -4 times -1, what is that? 4. So we have 3 equals 4 plus b. What do we have to do to get b alone?
Divide by 4.
Divide by 4? How about subtract 4? Yeah, I think I heard that too. I like that idea better. Subtract 4 because 4 is being added to b. So we're going to subtract it to get it out of there. What is 3 take away 4? -1. So we know our b value now. So remember, we can write the equation of any line in slope-intercept form once we know its m value and its b value. Do we know both of those? Do we know m? And we just found b, so what's the equation of our line?
-4x plus
It's not an equation.
3 equals -4 times
No. Equation of the line that represents any point on it. Written in slope-intercept form.
y equals -4x plus
So we substitute the slope and the y-intercept into our y equals mx plus b, just like you were doing in the last couple of assignments. When they give you the slope and they give you the y-intercept, you can write the equation of that line. This can be cleaned up. How can it be cleaned up? How would it really appear in an answer bank?
-1.
It'd be subtract 1 instead of add a -1. So here's the equation of our line, that any point on that line of that equation should make it true. So let's verify it with a graph. If we were going to graph this, we would say we have our m is -4. We now know that our b is -1. Oh, actually, we're going to verify that we have the right y-intercept. So here's what we're going to do instead. We're not going to worry about, we're going to pretend we really don't know the b value yet, okay? So we're going to go and say, well, what if I graphed it and I found the y-intercept that way? So we'll graph our ordered pair that they gave us, -1, 3. So put a point at -1, 3. And using a slope of -4, what are the two ways we can do a slope of -4? negative 4 over 1, make our rise negative and our run positive, or
4
positive 4 over negative 1. We can make the rise positive and the run negative. So from this point, let's use it both ways. So we're going to go down 4 and 1 to the right. We're going to go up 4 and 1 to the left. So our starting point this time was the point that they gave us. And from that point, we're going to make a couple of others, okay? Now, notice what happened. One of our points is the what? Is the y-intercept. And it is the y-intercept that we got algebraically. So we found the y-intercept algebraically, and the graph, and the graph already supports it. Okay? So let's draw a line, the line of our equation, going through those in our graph. Let me do that, see if I can do a better job. Does the behavior of the line match the slope that we were given? It falls from left to right. That's what we would expect the behavior to be. Okay. Well, let's find another point on that line other than the y-intercept and the point that they gave us, and let's see if we had used a different point, would we still have gotten the same result? Would we still have gotten the same y-intercept? Should we? Yeah, we better. Each line only has one y-intercept. So let's do this point right here. What's that ordered? This one here. What is this ordered pair's name?
His name is -2, 7.
Okay, so this one is -2, 7. Let's use that one and pretend that we still don't know what the y-intercept is and see if we still would get the same result. So we'll put 7 in for y. We'll put -4 in for m, because that's the slope of this line. -2 in for x. And we'll solve it for b. -2 times -4, what is that? -4 times -2. 8. What do we do next? Subtract 8 from both sides. 7 take away 8 is -1. We got the same result, and we should have. No matter what point you use that belongs to that linear function, they all should support getting a slope of -4. They should all support getting a y-intercept of -1. Any point on that line should make our equation that we wrote true. Okay. So here's the thing I want to, warn you. Here's what students do. Once you learn this and you learn how to use the point and the slope to help you find the y-intercept, you just go right to work doing it, and you don't take a moment to look at the point that was given to you and decide, did they just give me the y-intercept and I don't even have to find it. So if they give you the slope of a line, they say the slope of a line is 1/3, and it has ordered pairs 0, -1. Would you need to go through all of what we just did to be able to write the equation of the line? If they started out right away and they said, you know what, here's the slope of the line, it's 1/3, and it's got the ordered pairs 0, -1. Could you go right to writing the equation? What would the equation of that line be? The slope of 1/3
-1.
and ordered pairs 0, -1.
Y equals 1/3 x plus -1.
That ordered pair 0, -1 is the y-intercept. You don't need to find it. It's right there. X is equal to 0, so that's your y-intercept. So you can go right to setting up the equation and say y equals 1/3 x plus -1, also known as just -1. You wouldn't have to go through all that work. So pay attention, but you can't just do it all the time. You have to make sure the x value is equal to 0 to be able to do that. Okay? So any questions on that? Because that's the only practice we're going to do on that one. That's the thing. Only practice we're going to do together. And let's go to the back side and see what we have to do back there. We're gonna do a word problem. We have a caterer that charges a $200 fee plus $20 per person served. So you're gonna have some sort of an event where you're gonna feed people, and you're, in part A, we're to write an equation that represents the cost as a function of the number of guests. So in other words, it's saying cost, the y value, is controlled by how many guests are invited. So the number of guests would be the x value, wouldn't it? So this is really going to be our, when it writes it like this, cost as a function of, this is our y, this is our x, number of guests. Okay, so what could our equation be that would get us the cost to have an event based on the number of guests that you're going to invite? Blake?
Y equals 20x plus 200.
Okay, how many of you agree with Blake that that would be a good equation for this? Okay, some people. So, just because I wrote it down, that means it's right? Or you're going to agree because you think it is right? So, the slope of this one is what? 20. So the slope is representing, what is the slope representing in this problem? Shade, put that blue down. What is the slope representing? What is that 20 telling us? Brendan?
Cost per person served.
Cost per person served. So that 20 tells us how much it is for every guest you have, how much it's going to cost to feed that guest that you're going to have each. And then what's the 200, our y-intercept telling us? The starting fee, right? Whether you before you even calculate how many guests you're going to feed, they're going to also charge you that one fee of $200. So we've already really described what the slope and y-intercept represent, but we will let's write it down here. So m is 20. The slope represents the cost per person or guest, however you want to say it. Okay? Slope represents the cost per person or per guest. Our b value is 200. And we said the y, that's our y-intercept. So the y-intercept represents the one-time fee of $200. So to start with, right up front, before you even tell them how many guests you're going to have, they're going to charge you $200. When x is equal to 0, y is equal to 200. Okay, I've already got our coordinate plane set up for us. I've labeled the x-axis for us. I've labeled the y-axis for us. I've picked the scale. You go ahead and finish numbering out the axes. Finish giving numbers to these grid lines. So the x-axis goes by 5s, and the y-axis is going by 100s. And I'm going to keep taking points away on assessments for people who are too lazy to do this and or can't do it accurately. Now, when the scale does not, on each axis is not 1, that's when it gets tricky to graph slopes. So in this one, first of all, let's just go ahead and start with our starting point. We're going to put a point at 200 on the y-axis. Now, we're only going to really wanna go up from there, because if we start going down and over, we're gonna end up in negative territory, where we're not gonna have negative costs, nor are we gonna have negative number of people. So in reality, what we wanna do is we wanna use this slope only in the positive terms, 20 over 1. Does that mean we need to go up 20 grid lines and over 1? No, because the grid lines are not going by ones. So what we need to do is we need to rename 20 as a multiple of what the y's go by. What do the y's go by? 100. So we need to rename 20 as a multiple of 100. So what could we do to 20 over 1 to rename it? Judd?
Times 5.
Multiply by 5. If we take each of those, if we take the 20 by 5, that's going to change the rise to 100, which is going to make it a whole lot easier to do. But then if we multiply the upstairs by 5 when we're renaming, we have to also rename the downstairs. And how wonderful is that? The downstairs goes by our scale also in this case. So we're going to go up, not 100 grid lines, but $100 and over 5 guests.
Which is 1 by 1.
Which is just 1 by 1s, isn't it? So make a whole bunch of those. Up 100 over 5, up 100 over 5. And draw the line that this line is going to be a ray instead of a line, because we do not need it to go into any other quadrant. We only want it in the positive x and y quadrant. So we're going to have a ray here instead of a line that continues on at both ends. Okay, if our graph, we were doing this on a graphing calculator, we could let the graphing calculator do this for us. Or we could look at our graph. If our graph is large enough, we could use the graph maybe to estimate at least part C. Find the cost of catering an event for 200 guests. Can we use our graph? No. Our x-axis, we only really take it out to about 40. So we can't really use our graph. So what are we going to have to do instead then?
Plug it into the
Jen?
equation.
Use the equation.
Use our equation that we wrote. Y equals 20x plus 200. And 200 guests, is that our x value or our y value? That's our x value. So we're going to put 200 in for x. $20 times 200? 4,000. 2 times 2 is 4, and we got 3 zeros to tag along with it. And then plus our 200, that is what our y value should be. So the cost of catering in this event for 200 guests would be how much?
$4,200.
$4,200. And we can put a label on it because we know what the y is representing. Okay. So if we had a large enough graph to look at, we could go to x equals 200 on the x-axis, follow it up to the line, follow it over to our y, and our y value should be 4,200. We don't have a big enough graph to do that, so we're not going to be able to. We're going to do the algebraic way instead. Okay, so any questions on what we did on the back side here? Okay.